Hi, I'm Printed for Fun, and in this video I will scan this lawnmower with the Revopoint Trackit. There was a new software update for the Trackit, so I will test how it performs. So let's start with the setup process. I haven't set up anything, so we will start with my typical workflow. So you see that 3 pillar cases. Those 2 are for the Trackit, and this is the pillar case for my workstation. So let's start with this one. So what's in it? Here I have a workstation. It's a mini ITX build with a RTX 5070 Ti, 64 GB of RAM, a modern AMD 8-core processor, and fast Gen 4 SSD storage, so quite recent build. Then we have wiring, like extension cords, also like this small power strip, Wi-Fi antenna. Here we have marker blocks. Normally I use this for smaller scans in combination with this turntable, but I guess in this scan we won't need them since we use the Trackit. You can also see I have quite a lot of normal marker sheets for different scanners. We have 2 cans of scan spray, a power bank, camera, Quest 3 VR goggles. I use them sometimes in pass-through mode to, if I have to scan a car, I can put on the goggles and place the remote desktop window in the pass-through mode anywhere I need. But recently I've become more accustomed to using my, my tablet for the remote access, so it hasn't been used for quite some while, so maybe I will use this space for something more usable. Okay, so first let's start with the setup process of the workstation. It's actually quite straightforward. Just place it here on the workbench and get power to it. Of course, this could also be some sort of notebook or gaming notebook. But I found them normally, they also need a power strip, to be honest. Using that in battery mode isn't too much of a fun, especially when they have external graphics cards. So I thought to myself, let's simply have one build or one main PC and bring it with you in the pillar case. But this may change in the future. But for the moment, it's quite nice working. Okay, let's plug in the PC and boot it up. You can see I also have a quite substantial external Wi-Fi antenna. This isn't necessary for the Trackit since it requires USB connection, but for other scanners which are wireless, like the Revopoint Metro Pro or the Insta Rocket, it is very beneficial to have a proper antenna. So let's boot the PC. Now here's something quite interesting, I would say. When using the PC in this headless configuration, I could of course use the internal Wi-Fi as a hotspot and then use this hotspot to connect using remote desktop. But I found in Windows it's quite difficult to have the hotspot to boot at startup. There are possibilities, it's some PowerShell witchery and registry witchery, but it hasn't worked for me as reliable as using an external router. This is a very cheap TP-Link travel router, and I simply adapted it to use power from the PC. It uses only 5 volts, so normal USB-A is fine. And we have here this very short Ethernet cable to connect to the PC. So the PC is booting up, and I can now connect to my desktop. Let's see if it is already working. No, not yet. May still take a few seconds. Sometimes it also, with the new Windows app, it doesn't work reliably. It's quite a shame. Oh, I see I'm in the wrong network. So then it's no wonder the network I need is scan control. It's like the arbitrary Wi-Fi name I've given the network, but it could have any name. And now you should see I can connect to it. Yeah, okay, it's working great. So let's open the Trackit software. Track. This is the latest software version in the 5.7.3. I will also start OBS. This is only for me, like capturing the desktop view for you to be able to like see what I'm doing on my PC. Okay. Here it doesn't work. Okay, it should work. Force SDR. Properties, Force SDR. Okay. Now it is working. I can close this. Now I can move this case to the side and we can concentrate on the Trackit. I've made some workflow modifications to the Trackit, so it's like not 100% the original setup of the Trackit, but I found like my approach to be more convenient. I forgot to take one thing out of the case. It's the power bank I will be using to perform the scan, or to power the tracker. Now, let's take out the tripod. You see, here are already some modifications. I have this small 3D printed part to like stiffen up the tripod so the legs kind of close further. Then I have this holder for the handpiece of the Trackit, so I can move the tracker in one go without like needing to drag behind the handpiece. And I have this holder for the power bank. This is like a regular Ugreen, very big power bank. The only ability it needs is 12 volts output as USB PD, because then you can use it in combination with an adapter cable to like use the PD power output. So let's fix the tracker. What's interesting, I was at Formnext last week and there were like a refresh version of the tracker. It's supposedly the same spec, only 10 centimeters shorter, which makes it like more dimensionally stable, the set at the booth. But the performance is supposedly the same, maybe a bit, I wouldn't say worse. It still holds the specs they stated. But yeah, you can see I also attached, okay, I will turn off the Trackit. I haven't plugged in the handpiece yet. I have like this small cross-line laser mounted to the Trackit, so I can see where the tracker is pointing at. Like, okay, I want to scan the lawnmower, so I will point it at the lawnmower. But I guess like this frontal will be fine to have like a frontal position to the lawnmower. All right. Then next piece. Here we have the handpiece, just mounted to the tracker on my tripod. You can close this part. And then we need like the two main parts, or the main cables for the Trackit. There is the black cable used to connect the scanner to the tracker. It's like labeled 12 volt scanner. Keep in mind those are USB ports on the tracker, but I really wouldn't plug in anything else than the original scanner, because there's always like the risk of damaging your devices if you use it with any other USB device, since it doesn't like follow the regular USB power delivery protocols. it just outputs 12 volts statically, which can like fry your devices if they don't support it. Okay, here we have this. Then, like the next slide, I wouldn't say modification, but it's more like a security precaution. I have this very small USB extension cable. I use it to plug the Trackit into my PC in order to, like, if I trip over the wire, it just disconnects without ripping out my USB-C port. But I guess this isn't like a need. Well, if you're certain you won't do it, but for myself, I wanted some more peace of mind when using the Trackit. So we'll fix the two wires to the tripod. I've come to notice I get the best results, or like the best stability of the wires and of the tracker if I mount the wire to this back leg and have enough slack in them so pulling at the wires doesn't cause the tracker to wobble. If I have it like on the side legs and not in the center line of the tracker, it can induce some wobble into the Trackit. One additional change I did, normally the Trackit comes with a like regular quick release plate and this dual axis turntable. I only use the dual axis turntable when doing the calibration routine. For normal use, I use a normal, like a sturdy ball head, so I can freely position the tracker, like shown here. To move the tracker, leave some slack in the cables. Like I have like created a small loop, so don't risk damaging the USB connections. The next modification is a custom-made USB-C extension cable. To be honest, is not recommended using these cables, since like the USB signal quality is degrading over the extended distance and the additional connections. But I find it more pleasant to use the Trackit with this longer cable. And you see I have like printed end caps or printed plugs which allow the screws to engage so I can fix the connection. So now we should be able to boot the Trackit. I haven't calibrated the Trackit in its new setup with the new software version. To be honest, I don't want to do the whole calibration routine now since the last software update, because it takes roughly, I would say, 1 hour. No, not fully 1 hour, more like 45 minutes. It's not the most pleasant task to do, and I will try to avoid it. Okay. The handpiece is not showing. This is like one of the limitations of the extension cable I talked about. This is like not the most stable connection with this extension cable. And I guess I found the reason why it wouldn't connect. I used this small extension and it's quite funny. These extensions are often only pinned for one plug direction. So as you can see, I marked the direction. So I guess if I plug it back in now and reboot the Trackit, it should work. Let's get some tea in the meantime while it's booting. It's quite cold here in my workshop. That's also one reason I stored the Trackit not in the workshop. I stored it in an internal heated room, because the optimal scanner temperature for tracking or for scanning is between 25 and 35 degrees Celsius. And right in here we have maybe 5 degrees. So try to keep the tracker warm, have it like in a heated car, since it then takes up quite some time to heat. Okay. Yeah, no, it's connecting. All right. Let's hope it works. Yes, it worked. I'll have a look if it takes. Okay, toggle lines. So I just changed the setting for the manual key. Okay, acceleration, this looks fine. Maybe we'll do the calibration of the scanner, not the full calibration. Okay. It's at 12 degrees. Yeah, I'll skip it. I will skip the heat up time since I don't want to wait for this long now. So it can be, okay, that's one additional quirk of my extension cable. I forgot, you cannot do the calibration with the cable plugged in. I know it's quite a hassle, but hopefully Revopoint will come out with a longer version of the cable connection. Because you have to keep in mind the cable between tracker and scanner is 6 meters long, and the maximal like scanning distance or tracking distance between scanner and tracker is 4 meters. But now you have to add up. It's like if I'm 4 meters at a distance, I cannot like put tension on the cable, but because as soon as I have tension on the cable, the scanner starts to wobble and the scanning results will degrade. So what do I have to do? I have to like fix the cable down here in the tripod. Ideally, I would even fix it further down. And on the other side, the cable is like hanging in the air and moving down to the bottom. So it's more, as realistically, there will be like 4 meters left, maybe. And this is simply too few for good results. Okay, let's see. This is also the first time I'm using this camera for video capture. So I hope everything is working fine. Okay. Now it should be working again. Okay, so I'm back. I had to do a full calibration of the scanner actually. Initially, I just wanted to try calibrating the handpiece, or try calibrating it. I have to emphasize the try. Actually, if you start the calibration in like vaguely different environmental conditions, you have to do the full calibration cycle. It could also be due to the firmware update, but after only scanning the handpiece, calibrating the handpiece, and not the tracker and the hand-eye calibration, it simply didn't work. So the tracker wasn't seeing the handpiece. So I had to go through the full calibration routine. Here you can see on the picture the calibration setup. This is from the hand-eye calibration, and if we look a bit closer, we can see I mounted the tracker and the scanner on these two automatic gimbals with the yellow wires. Initially, like in the marketing material, the scanner often was depicted with the 2-axis gimbal still mounted when scanning. Or I've seen it on like YouTube, different users using it like this. I strongly advise you not to do it if you have to track it. Directly mount the scanner to the tripod or get a ball head like I did, since these 2-axis gimbals have some play. While calibration, it is no problem, but while scanning and moving with the handpiece around, you like start wiggling at the scanner and at the tracker, and this creates like all sort of problems where you get like a bad surface finish. It looks like a bit of this lemon peeling or lemon skin. So keep an eye on it. But yeah, another advice for the calibration process: don't use a power bank, or look exactly what power bank you have, since the tracker uses like all the 65 watts it can get from the original power supply, since the two gimbals consume quite a lot of power, like the two dual axis gimbals. And if your power bank supports this output, it's fine, but this one only supports 35 watts over 12 volts, so this is like, you have to keep an eye on it. And this is like a close-up of the hand-eye calibration. You see, I really need a new smartphone. It's time for it. It was not even that dark in the garage or in the workshop, but yeah, you see the quality of the picture. But yeah, so the hand-eye calibration is basically I guess it is for the marker tracking, or like the multi-position scanning, but I'm not completely sure. But yeah, so the tracker can follow the handpiece and can follow the calibration blade with these bigger calibration dots, and you can also see like the woolen surface they provide for setup of these two tripods or smaller tripods. So I've never had like problems with properly fitting them. After calibration, I did the scan, and I captured or did a screen capture of the scanning process, but in the end, only watching it, the scan taking place, it's not that interesting. So let's just look at the results. I guess that's easier. So I've taken 2 scans, or more correctly 3 scans, but I've used 2 scans to create like the proper model. I've also uploaded to Sketchfab, and I did an additional scan of from top to create like deviation analysis between the 2 scans, or between the 2 measures. Keep in mind, it's not accuracy, it's deviation between 2 measures. So let's start like let's go through the different steps in the Revotrack software you normally do when working with these scans. You can see I'm using my space mouse, and what's quite nice in RevoScan, since this is like the only scanning software I've used so far which actually supports the space mouse without problems. So you don't have like skipping origins, you aren't limited to zoom. It's like just free or normal space mouse usage. It's quite fine. So here you can see the raw scanning result. First step you're doing when you have the raw result, you perform the fusion. I already did the fusion, as you can see here. And there you can also edit the mesh and cut out parts. I don't need it, so I will revert the edit. You basically do this for all the parts. Then for me, the next step is, generally speaking, isolation and overlap detection. Isolation, like, removes small moving parts or not connected parts. As you can see, like these small data dots here, like this tank cap, I guess I accidentally removed it. And you can also set the isolation rate. It's like basically how large can you isolate the piece be. So if I select 84%, you can basically isolate all of the scan and delete it. But for me, I often, like for a very large scan with the trackets, I prefer to set it to like 1% or even less, to only remove like very small floating parts. Next one is the overlap detection. This removes like after merging multiple scans where you could have overlap, maybe due to like scanning errors, or simply like I accidentally moved the string, now there is overlap. It actually was the case for this cable here when turning the lawnmower around. What's very nice with the Trackit, personally, I haven't like really needed overlap detection since the scans align so well and there's very little overlap. Alright, so I did the same process with the bottom scan, as you can see here, and you also can see quite a lot of remaining grass and grime. So this I maybe, obscured the details a bit. Same process was done for the top scan in high detail. I will link to the post where I do the comparison, and this is mainly focused on the setup workflow with my Trackit and how to use it. Then after like initially editing the bottom and top scans, I merged them to like the full scan. You can see it is actually a bit lagging here since it has 27 million polygons. So that's quite a lot. Generally speaking, I try to keep it around 10 million polygons for uploads to Sketchfab, where I'm limited to 100 megabytes in the free tier. And I always use like the PLY format, exporting with quick surface. I must stay under 4 million polygons. So here you can get maybe a bit of a feeling how much I have to reduce it. One interesting addition, the merging step is done not with the mesh itself, it's done with the fused point clouds. So you create a whole new point cloud. That's also very nice in Quicksurf in Revoscan. That after merging, you get a new model. The model is like separately editable. You can edit it, you can delete parts, you can smooth it, you can re-merge parts of the scan to get like a high detail section you may need. So there, Revoscan is very, very nice, and like the core functionality is present in Revoscan 5, Revometro, and Trackit. But now let's look at the mesh and maybe get a small impression how it's scanned. This is no defect of the scan, there's actually a chunk of plastic missing. But yeah, I would say the Trackit captured the lawnmower quite nice, especially here on the like metal tubing. With regular scanners, even in feature tracking or marker tracking, scanning such long thin tubings without like laying it on the ground, creating lots of geometry around it and markers would be impossible. Also like scanning the pull string here, but you can see here it drooped a bit, I guess, while turning it around. Also looking here into the debug crevices, I actually didn't use the single line mode since I've just like discovered the new feature in the latest Revotrack software. We can press the M button for 7 seconds, for 3 seconds, and you get like a quick selection menu to select what function the M button should have on fly. So that's very nice, because previously you had to go back to your PC and change the setting. I hope they port this feature also to the Revometro software. So with my Revometro I Pro, I really crave for this feature too. So let's maybe take a look at the bottom, and yeah, it captured well. So as you can see here, we even have like the single strands of grass still clinging to the plastic parts. We captured the plate quite nicely, and especially the wheels are very complete scans, so from both sides. All right, so this was the video about the Revotrack workflow of the Trackit. If you have any questions left, just DM me or write a comment about them. And if there are like additional functions of the Revotrack you want to see, or like scanning setups you want to see, just write a comment. I have done a bunch of scans with the Trackit now, multiple cars. So I guess there will be, or there may already be some data in my backups I can use to like show it to you. But I will also like continue using the Trackit for my larger scans or scanning car parts. So there will be like some scans upcoming. All right. So have a great weekend.